Yo, what's up, everybody? Welcome back. I want to write a WebSocket server today. The sequence of events that brought us here. Oh, sorry, WebSocket client. I'm a liar, but I immediately fixed it, so it's okay. The sequence of events that brought us here is 20 years ago, my dad gave me this like 4x3 1280 by 1024 LCD monitor. And I've been using it since then. So for the past 20 years, it's been chill. For a while, it started taking like 5 minutes or 10 minutes to turn on. I believe what's happening is like the clock in the monitor that's supposed to like be used to like, sync with the desktop or whatever is dying. That's the only thing I think of that explains why it would take 5 minutes to turn on. It would like flicker on and off until it like finally locked, and then it'd be like good. Right? So that was the state for a while. It finally turned off all the way. Like never syncs anymore. Capacitor replacement stream one. Yeah. Okay. So why is this relevant? Well, when I try to use Twitch, I have this little chat window that I pop out. It just replaced my other window. Yeah, whatever. And what I do when I try to like hide this behind my camera now, right? And so like that ends up being a window that's like kind of like this, which is ugly. So then I start like going into here and trying to like nuke pieces of the layout to give myself more space. I'm like, okay, delete this thing, get this out of here, get this out of here. And then I close this and shove it back in the corner. Perfect. Now I get a little bit more space. That's not too bad. But this is like a stupid way to be. I would rather just have my own Twitch client. It's like a rite of passage anyway, so like screw it. This is a good opportunity to do that. We're 2 years in and we still haven't made one, so oops. And skimming the docs here, one of the ways to talk to the Twitch API is using WebSockets, which I believe is what we want. But that means that we need to be able to speak WebSocket, which we can't. So let's write a little WebSocket client. I haven't really done any research here. My understanding of WebSockets so far is like you send an HTTP request and then it like just turns into a binary stream at some point. That's about the extent I know. I Googled WebSocket RFC and got an answer, so that's kind of hype. So I think we just try to figure out what the hell this thing says. Try to implement a WebSocket client and see where that goes. WitCR, thank you for the tier 1. Much appreciated. Anyways, that's the sequence. Oh my god, I actually have to alt-tab here to see the time now, because I don't have my second monitor. This is where I usually do that. Okay. So, what does this document say? We read a little bit of this, and then I realized that we should do the learning on stream. As far as we got was, hey, this guy does a handshake. You call HTTP GET on some server. You ask to upgrade to a WebSocket, connection upgrade, I guess. And then you have some key. I don't know what origin here is for. I guess they're saying we're coming from example.com. I don't know. They have some protocol. I don't know if this is like informs the server of like what binary protocol we're trying to use. Maybe, don't know. And then I guess there's like some version header. I have no idea what part of this is required. But something that looks like this. And then he'll say, yo, time to switch. I think you forgot I used to have chat on that second monitor to tie these stories together. It makes a lot more sense now. Maybe I missed it. I did forget to say that part. Their chat was on the second monitor, and now it's not because the monitor's dead. Yeah, okay. So he says, okay, we have switched. Then the leading line from the client follows the request line format. The leading line from the server follows the status line format. I don't know what that means. They're defined over here. So this is literally just like HTTP shit. Okay, like typical HTTP shit. An unordered set of header fields comes after the leading line in both cases. The meaning of these header fields is specified of section 4 of this document. Beautiful. Additional headers may also be present, such as cookies, of course. The format and parsing headers is defined over here. Okay, once the client and servers have both sent their handshakes, and if the handshake was successful, then the data transfer starts. This is a two-way communication channel where each side can independently from the other send data at will. Beautiful. After a successful handshake, clients and servers transfer data back and forth in conceptual units referred to as messages. Okay, a message is composed of one or more frames. Okay. The WebSocket message does not necessarily correspond to a particular network layer framing, as a fragmented message may be coalesced or split by an intermediary. Right. So it's like they're saying like, hey, a WebSocket message does not correspond to like a TCP message, right? Like you can get split, or you can get like merged, whatever. Each frame belonging to the same message contains the same type of data. Broadly speaking, there are types for textual data, binary data, and control frames. Okay, and this version of the protocol defines 6 frame types. Okay, easy. So opening handshake, perfect. They're going to tell us a little bit more. So they send an HTTP request and try to upgrade. So I guess, can we like just try talking to some like echo server and see what happens? First of all, what port is this? Are we on port 80? By default, WebSocket protocol uses 80 for regular WebSocket connections and 443 for tunneled. Okay, so it is just like the same, right? Like from the perspective, you have like WSS URLs, but like from the perspective of the app, it doesn't really matter. Like you could call it HTTP and it would be the same, I think. Seems reasonable. So can we just like try sending something and see what happens? Can we do a little get me some zig in here, please? And can we do a little main zig? And can we maybe do like this? And let's do a little HTTP. How do you do one of these? HTTP client. What does this look like? Surely we can do something like this. He actually, no. Maybe like this. He wants an allocator, and then there's a lot of other like default options. How do we like attach this to a like a TCP socket? You know? We've got a connection pool in here. Can we look for like a test in here? Like how do we use this thing? How do we use this thing? Request? Okay, so we have one of these things. Who returns these? Request, here. Okay, so we call request on a client. So now the question is, how do we make a client? This guy takes a method and a URI and request options, who I assume has headers in him. Beautiful. Okay. So then I think we just make the client raw and figure it out from there. So can we do std heap general purpose allocator? And this gives us, this thing's kind of like not the way you're supposed to do this stuff anymore, but like fuck it for now. Why is he not happy here? Probably because this stuff isn't finished. Okay, and then can we do something like client request get from Google? Maybe. Let's just kind of see what happens here. And can we read the body or something? So we want probably to receive the start of this thing. Who wants some buffer? So I guess we kind of let him do that. And can we look at the head status? Okay, here we go. Got this. Surely it's something like this. Okay, he's mad because this guy doesn't have an init anymore. It's like this. Okay, he expected URI, so this guy must have like some parse function. Right. Parse. Great. Okay, fuck off. Okay. He's getting closer. This guy, we want client request should be var, I guess. Okay. And here he's pissed. Why? Maybe I need a little HTTP here? Okay. He's mad though? He's a little stuck, huh? Waiting now. Done waiting, right? I assume we're gonna find that we're stuck in that receive head. Probably. Am I crazy to be upset that the Zig code formatter doesn't put a space at the end of HTTP client? I mean, I'm the Zig code formatter. I don't let the formatter run unless I ask it to. Okay. That's interesting. Why the fuck does this not work? Why doesn't this work? Interesting. Interesting. What does receive head do? He's got like a little while true in here. If request of payload is present, blah blah blah. Can I not automatically follow redirects? Because I assume that this while true is just getting stuck, right? And does he like create the connection? Like, what is happening here? What is happening? Maybe try HTTPS? Oh yeah, I think you're right. There's like disable like TLS. There's a way to like force no TLS in here. How does he know if it's HTTPS or not? You're right that there's probably something there, right? I guess he must know based off of this thing? No, parse the URL. Yeah, I guess that makes sense. So this URI will tell us probably which port. So can we at least check that this is working the way I expect? Maybe, what the fuck did I just do? Here? It won't use TLS on HTTP, that makes sense. Stood, HTTP, stood, HTTP, net, HTTP, URI. There we go. No? Maybe something like this? Stood, URI, maybe? There we go. Okay, can we print this URI? Okay, so he does port null. I guess maybe it like auto detects it in request. Did you connect before request? No. I didn't really consider that I have to do that. I thought that it would kind of figure that part out. Okay, fine. So we're looking for host. We're looking for port. What a confusing API. Protocol. Plain. Alright. Alright. And then here, there is a connection that we can reuse in here. But like here, it should automatically figure it out, no? Like, if I would assume that this thing is like, if the connection is null, then he's like chilling. Yeah, I mean, this seems the same. But you are saying that there's a thing called fetch, which we could try. We could try this instead. Maybe we're missing some like required headers or something, and like he's falling the fuck over. Okay, what do we got in here? How do you read chat now? Just like an annoying Firefox window under my camera right now. Okay, what do we got in here? We have location, which is one of these, which is a URL or a URI. I see. Method should be automatically detected, probably. I don't know, let's just do this. Location is URI. URL is... Maybe it's like www is like no good. Could be as well. Something like that. This guy returns a fetch result. Wait, hold on. Let me just double check here. If we're like, go to Google. Wait, did we lose the request in here? We could try a different URL. Just in case. Just in case. It's like Google fucking us here. Okay. Nope. What am I missing here? What am I missing here? Zig HTTP client example. Can we just do this? He has an allocator. He creates a client. He does fetch. Okay, here he's doing what we're doing, right? He's like, here, let me fucking make me an allocator. Let me create a client with this allocator. He does a request here. And then he does a receive head. Right? Try hat. Try your website, sure. Very strange. Is this like not big enough? What am I missing? So we do client, make me a client. We have request, get, URI, default options. Oh, do we have to send the request, huh? There we go. There we go. Okay, let's go to google.com. We're so back. We're so back. We probably have to like defer rec dinit or something, right? We probably have to defer head dinit as well. No, okay. Okay, there we go. There we go. We're chill. We're chill. Okay. We got there. We got there. So now we can send an arbitrary request. So we should be able to go to this like WebSocket example. Which we lie and say is HTTP, right? And we'll see if he sends us anything back. Okay. He's asking for TLS, so we'll throw a little S on there and see if... Okay, we're chill. We're chill. So sick. And then we start trying to like slap in some of these headers that he asked for, right? So I guess, well, let's see what he responds with first. Let's see that. So this guy is going to give us a reader, I guess. And can we just do like a little, I guess we want to like pipe this into some buffer somewhere. So can we do like a stud IO writer allocating, initialize with this guy, and defer buff dinit, and then can we do like stream everything into our writer, and then can we say unlimited? And then can we print that? Let's see what he says to us. What does he say? Varhead here. Fuck off. I don't give a fuck about. Can we do stream all? Stream remaining? And I really don't give a fuck about this as well. Alright, let's see what this does. I guess this unlimited goes away. Okay. That's interesting. Is this giving us back the fucking TLS data? Can we try Google again? Well, that's cool. That's cool. Reader, body reader? What did we ask for? Rec. Maybe we're using this wrong? Request reader, body reader. Okay. So head reader gives us what? He gives us about body reader the same, but he is looking for like a transfer encoding here. What's going on here? None or chunked? Oh, maybe it's like gzipped? Maybe? Yeah, can we look at the headers here? Yeah, let's dump the headers. I agree. So can we look at the, like, head, 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 iterate headers. Var header iterator is one of these guys. And here we're gonna do while header iterator next. We have some header, and we print probably like header key and header value or something. All right. What? Dude, why is this so fucking buggy? Am I crazy? Do I have to do this like here before we call something else? Okay, there we go. And then if true, return. So child process exec curl, yeah. Okay, I assume that we're gonna see like gzip in here, right? Yeah. Yeah, okay, so this thing is like zipped content, so can we just like not fucking do that? Can we be like, please God? Please fucking God, don't let me do that. You're saying that the client requests is default accept encoding. So surely in here, default accept encoding. So this goes on the request. So when we who makes the request here? We are calling request here. So request options. But like he doesn't. I'm missing something here. Where does that come from? Because in the request. Oh, I see. So do I just like, I guess the request isn't sent at this point, so we can go like rec accept encoding equals this. Okay. We want like splat false. Which is yeah. I see. Fuck everything. Which he's like, okay, I need at least one. Fine. So what we want identity. Okay. Dude, there's gotta be a better way to do this. Right? Right? There's gotta be a better way. Like, surely. Surely. So now, are we no longer gazipped? I think so. I don't see gzip in here anymore. Okay. For HTTP, yeah, dude, for real. This is, I'm sure that I'm missing like the way to do this, but whatever. Okay, so now when we like run this, do we get like a fucking sane? There we go. That's text, at least. That's some fucking HTML. Okay, let's go back to the web server example. Echo WebSocket. What's this look like? Unknown host name. Unknown host name. Oh, org. My bad. Okay. So he's like, that's not okay, bitch. Bad request. Okay. Can we... So before, if we didn't gazip, was it bad request? Oh my god. Okay, well... Maybe... If we have gazip, like maybe he just doesn't support anything else. Right? If we say we do support gazip, he's fine, right? So he literally does not know how to not send gazipped responses. Right? Which is funny. That's funny. Okay. So we have to support gazip, which means that we just have to switch on the transfer encoding, right? I'm surprised. I think that this should do it automatically for us, right? Right? Like, it would be nice if the body reader... Oh, reader decompressing. Wait. Perfect. If the compressed body has negotiated, this will return decompressed bytes. Okay. Wait. There, he's fucking got us covered. He does, in fact, need a decompress, though. What is this? Where the fuck does this come from? Can we see? Is there an example somewhere? Alright. Sure, fuck it. Weird API, but okay. TX buff. Decompress buff. Okay. He's mad because buffer len is not big enough. Max window len times 4 or something. Just give it some room so it doesn't have to rebase so much. Let's fucking go! We fucking got a response. Finally. What is that? Like 20 minutes later, we fucking got there. 25. Okay. But we have a thing now. So this is like, hey, here is a thing. And it's like, you can learn more. So now we probably want to start like trying to upgrade, right? So we want to slap a bunch of this stuff in here. Which I assume, what is like sec WebSocket key? That's, okay. Header field is using the WebSocket opening handshake. It is sent from the client to the server to provide part of the information used by the server to prove that it received a valid WebSocket opening handshake. This must not appear more than once in an HTTP request, but like, what is it? Am I fucking stupid? Like, can I just pick anything? It looks like a base 64 value. This value is base 64 encoded. Here we go. Oh, this is telling me what base 64 is. But like, what is it? Like, what? For this header field, the server has to take the value minus any leading and trailing white space and concatenate this with a global unique identifier, this guy, in string form, which is unlikely to be used by network endpoints. Do I just pick a value? Literally like anything? But like, does it have to be random, or do I use my, like, can I just put like my name in there? The request must include a header field with the name sec Websocket key. The value of this header must be a nonce. Not like the British nonce, but like a one-time thing. Consisting of randomly selected 16-byte value that has been base 64 encoded. Okay, sure. Fuck it. Must be selected randomly for each connection. Okay, we can do that. Okay, so let's just kind of... Oh, wait, is this kind of just giving me all of the parts of the request? Whatever. Wait, I lost it? I lost it here. Okay. So let's, I guess, just make that. I guess. So somewhere, I guess when we're making our request here, we want to feed in some headers, right? So let's do make rec. Make sec WebSocket rec. Sec is for secure. Key, probably, right? So we return something like this. Maybe, do we know the size? We probably do, right? It's probably like base 64. Dude, which one of these base 64s is it, though? With padding? We do want padding. Do we care? Standard, surely. Surely we want standard. And in here, can we... Like, there's some way to get, like, the size of this thing, right? So we say, give me one of these back. Right? Surely. He doesn't like this. Maybe because we're not allowed to put const here. Okay, there we go. So we have stood base 64 standard encoder. We want to encode into this WebSocket key, maybe we can kind of do this to kind of make things nicer for us. And so we're like, hit me with this thing. Buff with as bytes of our random value. Probably something like this. So this is a int of U16. Okay. Okay. And then what does this give us back? Slice. But we don't want the slice. We want the buff. So we just like discard the slice. And return buff. Okay. So then somewhere we make a request. Sec WebSocket key is make this. I think that this guy is not a pointer, actually. I think random is the interface. So I think we go like somewhere stood random default pseudo random number generator initialized with some seed. Stood POSIX there's like some way to get a random number, right? POSIX get random number. There's some API for this. Get random? Yeah, here we go. Seed. How do we do this? We want like stud mem as bytes seed bang bang boom, and then we use it somewhere, right? So we have like headers, extra headers maybe, I assume, and I assume that this is cat w random. Yeah, I should have. You're right. He wants a bunch of HTTP headers which have name values, so we're like, name is whatever the fuck they want. Okay, I want like a second window of this thing where we go back to just that first example. Here we go. Sec WebSocket key. And we're looking for a value of sec WebSocket key. Easy. Easy peasy. Fuck. Is one of those 16s in bits versus bytes? Good question. Good question. Did he say 16-bit? 16 byte value. So surely calc size here is 16 bytes. Oh, but this is a 16-bit, huh? Can we just like fill a buff? Bytes. Yeah, you're right. Rand Val. You're right. You're right. Easy. Good call, good call, good call. This thing is somewhere, wherever the fuck that buffer was. This is a array, so we need to turn it into a slice. And okay. So we have got one of the headers in. We want to upgrade to WebSocket, and we want to upgrade this connection, right? Surely. Surely. Okay, and value is this. So we're like, please turn me into WebSocket, and please reuse the existing connection. Which I don't really know how this works with Zig's API, but we'll figure that out. And then, do we need like protocol? Sec webs. Oh, right, wrong window. I want to search that on the other one. Fuck. I guess we'll find out. Let's just run this and see what happens. He might get angry. Bad request. Okay, fine. We'll keep fucking looking. So, sec WebSocket protocol. May include header. Okay. Must include version, though. Must be 13. Okay. If you say so. If you say so. Oh. Very nice. Very nice. We got switching protocols, and we are a WebSocket now. Cool. So can we start, like, ripping some shit at them? Like, can we just be like, yo, dog, here's some stuff? Like, we need a connection somewhere, right? Because, like, are we just binary at the end? I don't know. I guess let's keep reading. Let's keep reading. So we send this. He gets back this thing. Then we need to send frames, maybe? On the wire, message composed of one more frames. So we have the opening handshake. He gives us some stuff back. He gives us a little switching protocols thing. These fields are checked by the WebSocket client. Nah. I won't check shit. Okay, option fields can also be included in this version of the protocol. The main option field is this, which indicates the subprotocol that the server has selected. WebSocket clients verify that the server is included one of the values. The server that speaks multiple subprotocols has to make sure it selects one based on the client's handshake and specifies it in its handshake. Okay, I probably don't care. I assume that this is like if you want to use some substandard, you can ask for it, but like maybe we just don't give a fuck. Design philosophy. There should be minimal framing, and the framing exists to make the protocol frame-based instead of stream-based and to support distinction between Unicode text and binary frames. It is expected that metadata would be layered on top of WebSocket by the application. Yep, we're trying to get as close to like a little TCP connection as we want. How do we, okay, subprotocols, that's interesting. Should be registered here. It is recommended to use names that contain ASCII version. Chat subprotocol is this, and then presumably we have some chat protocol RFC somewhere else that I don't really care about right now. How do I actually send data, sir? Sending, servers opening handshake, don't give a fuck. Yet. Data framing, here we go. In the WebSocket protocol, data is transmitted using a sequence of frames. To avoid confusing network intermediaries, and for security reasons that are further discussed here, a client must mask all frames that it sends to the server. What the fuck does that mean? Note that masking is done. Masking is like what those people on TikTok talk about masking sometimes, when it's like, I pretend I'm happy when I'm not or something. Masking. What does it mean when I'm masking? Right? It's like when you're pretending you're not autistic or something, as if symptoms are not present to the individual who is struggling with it. Oh yeah, when I'm like, I'm not depressed, but I am depressed. That's masking. That's probably not what they're talking about. A mask frame must have a field frame mask set to 1. The masking key is contained completely within the frame as defined in this. It is used to mask the payload data defined in the same section as frame payload data, which excludes this stuff. So we choose a value sometimes. Is this so that it's like hard for like snoopers to like figure out what I'm talking about? Doesn't TLS already cover this? Why does this matter? Oh, whatever. Sure. The server must close connection when we're not masked. Okay. The wire format. Okay, here we go. This is what I want to see. Wait, she said we have to mask, right? A client must mask all frames that it sends to the server. So then why is there a mask bit in this thing? Like, this is just always 1, no? Okay. Indicates that this may be the final fragment. Masking is, how are you doing? To fine, I'm great. Okay, good. Oh, what an idiot. I've never been more miserable in my life. Yeah. Okay. Client to server is always mask. Server to client mask is optional. I see. Okay, so we're like, this may be the final fragment in a message. Probably because there's like a maximum length to each message, because a message can be split over frames or something. The first fragment may also be the final fragment. Got it. These must be 0 unless an extension is negotiated. Okay, so we just kind of fuck off on those. Opcode is how you should interpret this stuff. So we have continuation frames, text, and binary. So presumably you send a text frame and then you're like, okay, keep continuing, then finish. If this thing's too large to fit. We got pings, we got pongs. Okay. Payload data is 7 bits. The length of payload data is in bytes, 0 to 125. So if we're over this thing, whoa, hold on. 7 bits? 7 plus 16 bits or 7 plus 64 bits? What? Oh, I see. What a weird way to encode this data. So if it's... Oh, I see. You're like somehow packing 64 bits of info in 1, 2, 3, 4, 5, 6, 7, 8, 9. We can count. This is 10, 14 bits. Oh. No, wait. So this is 32 bits plus... Yeah, I mean, no, it's still here. Why the fuck does this exist? 30, because this is just a 64-bit field. Why would you not just always use 64 bits? Is this an optional section? Oh, yeah, I see. So if the value, I see. So if the value is 126, then we continue here. Then if the value is 127, we continue here. Easy. Okay, easy peasy. Masking key. This field is present if the mask bit is set to 1. If the mask bit is set to 0, we can probably pick a random value, I assume. And then you probably XOR all your data with that thing or something. Payload data is defined as extension data concatenated with application data. Extension data is 0 bytes unless extension has been negotiated, which we have not. Application data is the stuff that we want to send. Okay, cool. So we can just like rip some shit now, right? Presumably. We should be able to like create a packet. I don't know. Write the WebSocket frame into some writer, right? And we probably have some like options. And what goes in here? We probably are trying to write some data of some opcode, right? So opcode is something that fits in a U4. And probably should be an enum, to be honest, but what kind of, enum would be better here? And then is everything else just derived from the data? Probably, right? You read this left to right due to little endian, right? Great question. When encoded on the wire, the most significant bit is the leftmost bit in this form. So this is most significant bit. Isn't web big endian? Yeah, it feels like that, right? So we kind of go in order here. So we should be able to. How do we want to like encode this data? We have to do it in bytes, right? So this is 1 byte, 2 bytes here. Yeah, okay. So I guess we like have to split data into packets, into frames, right? So we do something like we first check, like, we probably need to determine which packet type we are. So we probably have like remaining len here is len, this, right? And it's probably something like while remaining len is greater than 0, we switch. Do you have like ranges of switch in this language? I actually can't remember. Like, can we do this? Zig lang ref. I think that we have that in this language. Yeah, okay, cool. It's triple dots. Is triple dots inclusive or exclusive? These are inclusive of both ends. Okay. So if we are in the range of 0 to 127, we are in case 1. Then we have 127 to to 126. 125 even. Then if we are in the range of 125 to or 126 into No, this would have to be 126 onwards, yeah. So if we're in the range of 126 to, what would this be? 2 to the power of 16, right? And then if we are in the range of this to, what is the next length? U64, right? How could we ever be larger than one U64? That's so big. Right, am I crazy? This is 32 64-bit numbers? Why would you ever need to split? Yeah, I mean, that's crazy. So, like, for now, we just do this. Because I'm sure that there's going to be a reason to do that later, but I don't know what it is yet, so we'll just do this. Right? Surely. Okay. So then we want... probably we want to, like, spit this stuff into chunks, right? So probably we write WS header first byte, and this is gonna have like first byte options. Okay, I don't know. So we have Finn. Can we actually just do this instead? Maybe we just do WS first byte is struct U8. And then we don't have to do this. This seems fine. Oops. And then I need to look at the packed struct stuff. So packed structs, is it the first bit? Logical sequence of bits arranged from least to most significant. Okay, and then this is arranged from most to least significant, right? The most significant is on the left. But we can do it in either order, and then we can just encode it as little or big when we do write struct. It doesn't really matter as long as we're consistent, I think. So we got Finn, we got... No, you can't? Oh. That's for byte ordering? Yeah, you're right. Finn, RSV1. Well, then, in my mind, are they not saying the most significant is on the left? So I feel like we go opposite, no? Am I stupid? Op. Okay. Let me just double check this. Finn comes last in this format. They're saying the length of each group of bits is indicated in comment. When encoded on the wire, the most significant bit is the leftmost. Am I crazy? This sounds like most significant to me. Which would make it the last thing in my struct, no? Because here, arranged from least to most significant bit. Least to most. Right? So if I want this to be the most, it has to be last. Is what I'm reading from this. Which makes me think it's the other way. But we can test this, right? So we're saying... Well, also, how is this chunking? This is big endian. Right, so it's like bytes come in order. Which is what I've said twice. Oh, I thought you said Finn comes first. I just can't fucking read. I literally just thought that you said the other thing because I wanted to disagree with you, I guess. I think I just thought you said the other thing. My bad, my bad, my bad. Okay. So we can be like, hit me with a right struct of the first byte. So in every case, this is going to be the same. So for now, we're going to assume that Finn is true, right? Because we're like, in what world can we not fit everything here, right? Like, so this has to be the last one. Unless they mean it's the final packet of the entire fucking stream. In final fragment in a message. Right, so, sure. RSV 1, 2, and 3, they said are all nulled out unless you've negotiated extensions, which we haven't. And in the opcode, let's say that we're a binary frame for now. So op is 2 binary for now. That way we don't have to worry about like UTF-8 parsing and stuff like that. And we'll hope that the echo server knows how to respond to that stuff. If you wanted to send 2048 blocks at a time in a huge file, but like, am I crazy that like, if you can encode a payload of 2 to the fucking 64 bytes, like you'll never run out in one frame? So it must be like if you're like late, it's like if you're reading by a buffer, right? It's like the same thing as like the PNG format has like a multiple IDAT sections back to back because you're like, I read into this buffer, send, read into this buffer, send, read into this buffer, send. I don't have a fucking 2048 byte buffer to send, but like, yeah, maybe you want to do like some like transformations on that data. Sure, I could see it. Maybe. Okay. So also your HTTP packets should be smaller than 1400. But like at this point, we're not in HTTP packets anymore, right? Like here, we're kind of like almost like raw TCP, right? Like, doesn't this get like, we've got like a TCP stream that we're talking over? And this thing like is on that layer, I would think. Right? You're no longer, like, we have like one long fucking HTTP connection that's like no longer HTTP. It's just like data, was my understanding. But maybe I'm a fucking idiot. Okay. So second byte is a U8 that has mask, which is down here. And then we have you can send a U16 max packet in TCP, but that will get fragmented on the wire. Sure. But isn't that fine? If it gets reordered, your latency goes to hell. Oh. So is there some like application way to avoid that by not queuing everything at once or something? Yeah, okay, sure. So you're kind of like trying to treat this thing almost like more UDPE by fragmenting the data yourself. But then they still get transmitted in order, no? Like you can't do like WebSocket over UDP as far as I understand. But maybe there's some sort of application stuff you can do to like reduce the cost. Okay, sure. So we have this. And let's just unreachable here for now. We just won't support these other cases yet. And then here we throw the data in. So it's like WS second byte. We probably need to try here a couple times. And we have payload len is data len. And we probably intcast this. Okay, and this is safe because we've already checked the length is okay. And then masking key. Oh, but here we still have mask is 1. We have to mask. And then here we send the masking key. So masking key is just a U32, right? So can we just do like masking key is dead beef? No, we don't like dead beef around here because we don't eat meat sometimes. So can we say cafe food maybe instead? We like cafe food. Dead baby, yeah. We're not okay with dead beef, but we're totally okay with dead babe. That's crazy. That's crazy. Okay. Can we do? We just write the mask, right? Write int. Masking key big. And then, oh, this is 32 bits. Yeah, we're good. Okay. So this has to be U32. And then we have to send the data, which I assume that we have to apply the mask to, right? All frames sent are masked by this. This field is present if the mask bit masking key is within a frame, 32-bit value. When preparing a mask frame, we must pick a fresh masking key from the allowed set of 32-bit values. Oh, so it must be derived from a strong source of entropy. Oh, so there's a list of allowed values that we can pull from? Okay. Must not make it simple for a server proxy to predict the masking key. So, are there allowed keys that we're supposed to like index from, or do we just pick up any fucking U32? Okay, the masking does not affect the length of the payload data. To convert masked data into unmasked data, or vice versa, the following algorithm is applied. The same algorithm applies regardless of the direction of translation. So octet I, which is a byte of the transformed data, is the XOR of octet I of the original data with octet and index I modulo 4 of the masking key. So we have I mod 4, J is I mod 4, this. Oh, sure, sorry. So this is a 32-bit value. Right. So we go for each thing in the data, we have byte and I, and we're trying to like write byte here of the value of here we want fuck. This is going to be easier if we actually store this as a bucket of bytes, I think. So here we do like cafe food, right? And then instead of writing an int, we write bytes here. Yeah. And then here we can take B XOR masking key I %4. Right? Something like this. Right? Something like this? The payload length indicating the framing as frame payload length does not include the length of the masking key as length of payload data. Okay, easy. So I think that's it, right? Right? That's the packet? Because the size is kind of here. I think that's fine. So we should just be able to like rip that shit now. How do we send this? Where does this go? We probably have some like, is it just in the connection? Where does the connection live? Probably like head maybe? When we construct a reader out of this thing, like where does he get? This is an HTTP reader. We have a connection here in the request. Does this thing get set after the connection is made? Probably, right? Surely by the time we are connected, we have a connection. Surely, right? So we probably have like this guy, and we can just like write into that thing. Maybe? Oh, this is like this. So can we just start like ripping shit in here? So write WS frame hello world, and then we should have used op here. Like this. Okay. And then can we just keep reading from this thing? Like, is this just from like the fucking raw connection now? Right here, we probably want to read 1 byte, right? And see if this looks like the first byte. Maybe. Right? Like something like this. So we have like this decompressor stuff here, but then probably once we've upgraded, we're no longer G-zipping everything, right? Surely. Surely we're fucking chilling. Surely. Response byte is this, and then can we do a std debug print of the response byte? Surely. Surely this is fine. Okay. Right struct is pissed because we need to say that we're big endian even though our struct is only 1 byte large. He's mad because the masking key here has to be coerced into a slice. You might need to compress the data to use that writer. Yeah, I don't know. We'll find out. We'll find out. Okay. So he is just kind of sitting there. Can we ask the idiot? Maybe this is, if I'm making a WebSocket client, if the HTTP connection is gzip encoded, does my WebSocket data also have to be gzip encoded on upgrade? We'll see if he knows. No. He just says he doesn't inherit it. So that lines up, but then why aren't we getting anything? Because we didn't flush. Gotta flush. And then can we like kind of take a little peeks? Hi, Mom. And then here. Waiting now. Whoa. Why isn't this happening at all? Oh, because this is stream remaining. Stream. We want to stream till we see /r/n, right? That's what we're trying to do, right? This guy's going to give us an HTTP. Does this give us anything? Like what? Like the body of this thing should be null, right? On the response. I think we just like don't do this or this. Or do we not do any of this? Are we literally just like, we got our header and we're fucking good to go? This header should tell us the data length, right? Content length, right? So here, I guess like assert that head content length is equal 0. It's not. Okay. What is it? Oh, it's null. which I guess is the same as 0, probably. Okay. Oh, nice. So we got a thing back. He thinks he's opcode 1, which is concerning. And let's just double check also that there's no data available at this point, right? Like, before we send anything, if we try to read this thing, we should fucking freak out. I think. So this is not hanging, which is scary. Maybe he sends us a message like off rip. You know what? Like even before we send anything? It could be something like that, right? So maybe we try doing something like read WS packet. Okay? And let's figure out what goes in there. So we have write WS frame is a better word. Read WS frame. Okay, and oopsies, my bad. You guys got to see. It's too big. Okay, so it's probably gonna resemble write WS frame, right? This is gonna take a reader. And I assume that we don't need options here, right? And we're probably looking for some data. Maybe we're looking for more, who knows? We're gonna read the first byte. So we'll say we have a read WS frame here. It might be different than a write one, who knows? But we'll just kind of see. So then we have like data like this. And here we are going to take struct like this. First byte. Then we have second byte. Boom. And then here we're switching on second byte payload len here. And we are asserting the first one. And then we are reading the masking key. Which is present whether or like the packet will contain this thing whether or not that's there, I believe. Masking key if mask set to 1. Okay. Else we use like unmask key, right? Just to make the code easier. Right? I think it makes sense. I think this works. And then we say, can we rewrite the data in the read buffer? I think there's no reason that we can't do that, right? So we want to do like option, like a reader take, however many bytes this is. So payload len. And we want to go for buff 0 onwards. We take that byte, so we take it mutably, and we say b XOR masking key I over mod 4. I think that makes sense. And then we can return I don't know. Do we not use this first byte at all? We will. We're going to return op is first byte op, and then we're going to have data is buff. And as long as the reader that we're using can buffer the entire message, we are fucking chilling. If it can't, then we're going to have to get a bit more clever, right? Maybe this should give us a, you know, a like reader interface that like does all of the unmasking on read. You know, we could do something like that, but for now we're just going to do this. Okay. Wrong return type. Yeah, true. All right. So can we do while true, get me some packet, comment all this out for a second, and can we std debug print the op of this and data of this, and just kind of see what happens? Probably this has to be tried. All right. Let's see if this guy says something to us. Oh. This is 126 and 127 are our other options here. Okay. Do you want unmasked to be a NOP? B0 is the NOP, not B1. Oops, my bad. My bad. I thought it... Yeah, you're right. XORing with ones... What is the truth table? 0, 0 goes to 1. 1, 0 goes to... No, this is the other way. 1, 0, 0, 1 goes to 1. And 1, 1 goes to 0. So if we fix one side to 0, we have these cases, which is the same. Yeah. XOR, not OR. Good point. My shorthand is toggle. Yeah. I mean, I knew it was toggle, but I had to like write it out to like get it. Yeah, so if we fix left to 0, it's the same, and if we fix right to 0, it matches left. Yep. Okay. Thank you. Mask, he's pissed. Why? Because I didn't write try over here. Okay. Request. Wait, this is text. That's some fucking text, baby. Okay, so now, what we want to do is we want to, before we rip this shit, write some shit, right? So let's before we get anything, write hello world as binary, and we'll see what happens. Interesting. We never see that. What if we write it as text? We are never seeing our response, which is not good, right? Either that means that we're writing a malformed thing, or we're missing something. Okay, can we maybe do a little bit more here? Can we see std debug print waiting for new message here? And let's see if we're getting like any component of this thing, right? First byte, right? This will let us know if we're actually getting in there at all. Right, so here the echo server is not even attempting to respond to us, which is concerning. So we do flag this thing as finished, and we have fair confidence that our opcode is correct, because we're seeing the response get the opcode in the right spot. I think let's like see what they send us also, right? We can kind of do this just to confirm, right? So they send us something that looks the way we expect. I guess technically it could be backwards and we wouldn't notice because it's like symmetric. But if we're sending this, then it should be fine. Okay. So then we are masking, right? So when we get what they see, we have. Can we see what their second byte says? So they are giving us payload length 32, mask 0. Is that the right length for this? Yeah, it's got to be. Oh, we should double check. So this is. How do you do this? Echo this. 33. So sure, we're getting like a new line probably, right? Yeah. Okay. So our payload is what we expect. Let's make sure that we're writing the right thing into our payload. So we are writing mask 1, and then we are writing all of the masking key. I guess we could get this part wrong. Masking key is 1, 2, 3, 4 bytes. So that is 4 bytes here. And then it's literally just payload data. What's your return code? 200 or 101? When I send my initial HTTP request, it's 101, right? We're seeing we see a log that says got switching protocols, which should be 101, right? So it does seem to be doing what we expect there. I wonder if it's something like we're not allowed to use this underlying writer this way. Although it seems like it should be fine. Maybe we have to send this after the first thing. We could try this. Get this first, then send something, then try to read again. Right? Maybe they have some ordering constraints on their end. No luck. I think it's dumping you a blob which you have to seek past. But like we are receiving a valid message before we send anything, right? But maybe there's like something here that we have to look at. Let's take a look. Okay, let's look at the constraints of this echo server. How to use the echo server. They try to how do they send? So they send a JSON blob over where they have socket here as a new WebSocket. Okay. So they have basically just socket.send. So they send a test message as a string, then they send another JSON blob. Try sending a single binary byte after reading the new message. Oh yeah, I guess we know that we're sending something, right? We know that we have data that's getting sent out. Okay. Because like this isn't like hanging or anything. Scroll down a bit more. I'm not sure what you mean. Echo. Oh, we need to. Okay, we have immediate echo with minimal latency, message preservation. So these are just everything that it says. We don't have to like negotiate with this thing at all, right? It's literally just calling a new WebSocket here. Interactive testing interface. Yeah. So this is how it's supposed to work. Okay. So if we do this, do we see any like webs? Can we like watch WebSocket stuff here? Yeah, you kind of can, right? So this guy is sending. It's like kind of giving. It's too high level. But this is what's supposed to happen. So what are we doing wrong? We did kind of skip over masking key constraints. Right? We kind of just picked something, and that key could be mad. Connection keep alive? Yeah, like in... Well, our connection is alive, right? But you are right that we might want to, like, specifically ask for it. Any other server will send 100 continue, set this to false, and wait for a response before sending the body. We have connection here. I'd agree it's alive if you got everything back. Yeah, it seems... Does Writer actually send with flush? It should. What is, like, this writer? Connection is a HTTP connection? What is this writer? This is literally just, like, the underlying stream writer. So if we go, like, writer here, if we are TLS, he is trying to TLS encrypt this stuff, which seems bad. Oh, but I mean, the reader is TLS as well, so that seems good. So all that seems fine. What if we do this? Just like send a bunch of things in a row. Okay. So if we sent a lot, it does work, right? We see ourselves getting back a hello world, which is good. That's very good, right? So it's more something about us probably not finishing this thing correctly. Are you sending the length? We should be. We got payload length here as options data len. But it does feel like we're like fucking something up. Right, we're also seeing like an unreachable on discard. Where is that discard happening? From D init. Oh, sure. So we should be doing like while true here, maybe? Okay. So we do see 1, 2, 3 hello worlds. 1, 2, 3. So it could be that maybe we have to wait for some amount of time to do it one time. Maybe. Maybe there's some bug here. Stood, thread, sleep for 1 second. One Mississippi, waiting for a new message. Very fucking strange. What if we just flush multiple times? What? What the fuck? So if we do that, we get one back. What? Does this not flush out everything? What? I mean, it's possible. I thought that the flush call was supposed to force. Drains all remaining buffered data. Okay, so we do it once. Nothing. Like Andrew says, make sure to flush multiple times. That's so strange. That's so strange. It has to be a bug in like the TLS stuff, right? It's like, it's probably the fact that we have the TLS writer here. And probably like What is client writer? The TLS should send single bytes? But is it like flushing? Is it like flushing to the underlying stuff? Like, is it possible that like the first flush is flushing the buffer to the fucking like to another buffer? Like if you have like writer 1, writer 2, writer 3, like is this supposed to like when you flush on the writer 1, does it just flush to the buffer of writer 2 or is it supposed to flush all the way to the bottom? You know? You know? I mean, we could take can we somehow get information here? Can we S-trace this? Right, so like we should see somewhere a write to hold on. I guess we're gonna see encrypted data, which is not very helpful. Which is not that helpful. Check the buffered length of the intermediate writer. Yeah, so we have like rec connection writer, but this is like the stream. Where's like the TLS client coming from? So we say field parent pointer connection. Oh my god. Can we like pull the TLS out of this thing? All right. Well. All right. Where does TLS live? This is in connection. No? There we go. Is this public? No, so we're fucked. We literally can't look at this thing. Right? Is that it's impossible for us to get a handle of this because this is a private type? That's annoying. Maybe we have to copy paste the standard library. Can we check at least if this is on buff? Like, you know, something like this. Maybe this will at least tell us if it's like an immediate bug. This should be 0, right? That should be 0. Fuck me. Okay, so that is 0, and if we don't flush, you know, this thing will be non-zero. Can we get this, like, sleep out of here, by the way? It's fucking annoying. Okay, yeah, so it is buffered here. And presumably what happens is the connection writer is a TLS connection, right? We have TLS client whose writer gets his vtable initialized somehow. Jesus Christ. Surely it's this guy who advances the output, right? Yeah. Right? So this guy is writing to the output buffer, right? Because advance won't flush. So look at the connection writer, that's just the TLS writer. But like the TLS writer is what I have, right? So the TLS writer I think is flushing when you flush the TLS writer, he is writing the like buffered text to the output of the connection. Oh, you're saying the underlying thing is the connection writer, which we should just have access to, the stream writer? Yeah. So probably, I bet you what's going to happen here is if we look at rec connection stream writer buffered len. Writer, hello, what is this? Stream writer. We're on fucking Linux case, so you have like interface in here. Okay, so probably here this will show something. So it's 40 bytes, and then if we flush again before this, it's 0. Dude, that's gotta be a fucking bug, right? Is that really how the IO pipelines in Zig work? Right, so what's happening here is this flush must be like propagating it in some cases when the length is 0 and not propagating in the other cases, right? It's got to be something like that. Jesus Christ. That's got to be a bug. I'd report that. It has to be, right? So where's this TLS writer again? Let's just take a look at like if we can find where that is supposed to happen. So we have flush implemented somewhere, right? And so this guy, he does output advanced. So what probably happens here is hold on, let's go back to our little example. So we call flush, which literally just passes through, right? So maybe he calls advance. So what's gonna happen here? We're gonna have writable slice greedy min bufferlen. We're going to prepare a ciphertext record on this thing and then advance the output, right? So this is like the interesting part. Yeah, where I don't even see anywhere where that, like, I don't understand why it's not always doing it. You know? Like, because in here, I don't see anything that indicates that this will flush the underlying writer. You know what I mean? Like, this calls just flush on myself. So we get myself here. Unless there's some, like, degenerate case here where the length is 0. Right, so we have like bytes here. We're looking for bytes len is 0 somewhere. No. What's the buffer size of StreamWriter? I mean, that shouldn't make a difference, right? Because unless the second write is advancing the length or something. Very strange. Yes, because TLS has extra overhead. Yeah, could be. If like maybe my TLS buffer is inappropriately sized as well, there could be something there. The overhead on the second flush triggers apparent. Yeah, it does seem like it could be something like that. Yeah, so what is the length? The stream writer buffer? It's pretty fucking big. Pretty fucking big. So I don't think that's it. It seems impossible that we're going over that, right? Because again, like that wouldn't trigger flush, yeah. Very strange. Very fucking strange. Okay, we have maybe like 20 minutes to look into this before I want to call it on the video. So, because I think that at the very least, we have proven that we can communicate with WebSockets. It's just that like there's something fucky-wucky going on with the Zig APIs here, and I think that's worth looking at. A lot of this doesn't feel great, to be honest. Like, I wouldn't... It seems like this whole API is like really hard to use correctly. But I mean, let's be honest, I didn't look too closely at anything here. So there's something there, but let's just try to figure out. I guess there's a chance that we are not going into the same flush that I think we're going into. Can we just like hit the debugger and see where this goes? Def LLVM equals true. Is it just LLVM like this? And then we can probably do a little bit of GDB main, and we can kind of set a breakpoint here. Okay, well, fuck you, I guess. I guess we'll fucking get GDB. GDB main, breakpoint here, run. Okay, so he is going into TLS client flush, which is what we thought, right? And then let's step into advance here, which doesn't do anything too exciting. Wait, we need the double flush. Which we have, okay. GDB main. Run. Oopsies, breakpoint here, run. And let's just kind of spam step, I guess. We'll spam some steps just to see where this guy goes. He's doing some ciphertext shit. He's still trying to build this thing up. Okay. I guess the second one is the more interesting one, huh? So we go next, step in here. So here we should see that like almost nothing here is interesting. Oh, okay. Oh, okay. He did do a rebase here, which is interesting. Okay, so does this rebase trigger a write here? It might. We have default rebase. PW buffer len. PW end. So there's lots of room here, but he is still triggering a drain anyways. I see. Okay. Interesting. That's gotta be a bug, right? That's gotta be a bug. And then probably that just doesn't come up often because there's always more data to write. That's 100% a bug. Okay, well, cool. At least we understand it. Maybe we can try to fix that later. But this is we'll see if this is still present in master later off stream, and then we'll see where it goes. But here we'll say Zig's TLS writer does not force a flush on the underlying stream. A second flush triggers a rebase on the buffer, on the underlying buffer, which results in a flush to the results in a actual write. You should have a stream counter for Zig bugs. Yeah, I mean, this is only like the second like really egregious one we've hit ever, right? The last egregious one was the shared object DL open thing where it was not properly restoring registers after a call to thread local storage stuff. But this is like only like the second like pretty bad one. So cool. All right. Well, we understand WebSockets. It's not that bad. It's really not that bad, right? You send an HTTP request, you ask it to like upgrade you, you create a mask, and you fill a header with some stuff. You say, I will put all of my data in one, easy peasy, and I will say I am text or binary or whatever. You say, okay, let me give, I am masking, I am sad, I am happy. You throw your payload length in there, you write the data. If your payload's too long, you just, your payload length destination gets like a little bit more complicated. But otherwise, you literally just like iterate byte by byte, mask the stuff, easy peasy. When you read, you do the opposite. And then it's not that bad. Not that bad. So if we wanted to write a real WebSocket implementation, we gotta be like a couple hundred lines. So we'll see where we go from here. Probably tomorrow we come back and we try to like have a proper WebSocket API so that we can write a Twitch chat client that uses it. Maybe we take a look at fixing this. I assume that this is like a one-line fix though, so maybe I just file a bug and let them do it. We'll see. Or maybe I do it off stream. Who knows? Anyways, I think that's enough for now. Thanks for watching, guys. I hope this was interesting. If you liked what you saw, there's a Twitch stream if you're watching on YouTube. There's a YouTube if you're watching on Twitch. Some subset of stuff ends up on the YouTube. Some subset of stuff does not. Basically, if I don't think that it's like titleable, thumbnailable, or whatever, or if it's like too long. Some stuff goes on Patreon, YouTube members / Twitch VODs. If you pay in the appropriate place, you get access to the other VODs, or you can catch us live for free. So, cool. Let's call it there. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid. How do I end this now? Here.